We are like action camera. Okay, boys and girls, we have a very important things to discuss today before we move on to questions. अभी कुछ किया नहीं है हमने. We have simply worked out the resistance series parallel, temperature coefficient of resistance. उसके थोड़े से क्वेश्चन आप करोगे. We have a very important lecture today. It's very simple. It's very simple, but it's very important. ठीक है? EMF. EMF basically means electromotive force. It is the difference of potential between the electrodes of a cell for an open circuit. It is the difference of potential between the electrodes of a cell for an open circuit. That is, when we are not drawing a current from the cell. That is, when we are not drawing a current from the cell. What do we mean by saying? तेरा Pablo Picasso. It is to maintain across the two ends of a conductor. Okay? That I've used my words very carefully. Instead of potential difference, I have chosen difference of potential. In usual books, it would be written potential difference. But with potential difference, it has become so mechanical that we will always write V is equal to IR. Potential difference across the ends of a conductor is V. The current is I, the resistance is R, V equal to IR. That is the potential difference. This is actually the difference of potential between the electrodes of a cell for an open circuit. When we are not drawing a current from the cell. This is the energy which is there to be supplied. Because a cell will always have an electrode at a higher potential and an electrode at a negative potential, like positive. Usually we have a Lagrange cell. The cell that you use in your torches is basically a dry Lagrange cell, which is also available in a button form now. ठीक है, but one उसको अगर आप उल्टा करके लगा दो नहीं चलेगा. ठीक है, because one end is at a higher potential, the other end is at a lower potential. The usual cell which we put in our remotes, तो you know उसका plug करते हो, उसके ऊपर एक बोतल बनी होती है. That is basically the positive potential. That is basically a carbon electrode, and it has a container made of zinc. ਉਹਦੇ ऊपर प्यूरिफिकेशन कहती होती है, रेड है रेडी. ठीक है, उसको हटा दो तो नीचे से वो जिंक का निकलता है. But at the back it's like this. It's this color. So ऐसा तुझे लगा देते हैं. One end is at a higher potential, one end is at a lower potential. Suppose करो the positive potential is 0.8 volts and the negative potential is minus 0.7 volt. What is the EMF of the cell? 1.5. Now once again, the difference of potential between the electrodes of a cell when we are not drawing a current from the cell, the positive potential is at 0.8, the negative potential is at minus 0.7. Therefore, the potential difference available to us to maintain it across the ends of a conductor is called the EMF. कि बैटरी ਦਾ जो potential difference available है ਜਿਹੜਾ ਤੁਸੀਂ which you want to apply across the ends of a conductor अभी किया नहीं है which you want to apply the available energy basically it is the available energy per unit charge the available energy per unit charge बहुत लिखो ना क्योंकि तुम फिर दोबारा उससे ऐड भी करोगे ठीक है so it is not एक गल है इधर यूनिट्स की है लिख लो units volts क्योंकि it is the potential difference between the electrodes of a cell then why is it called a force I think it's a misnomer why is it called a force note down EMF is called a force because it drives the electron. Inside the conductor. Under the influence of a potential difference. Drives were underlined below. EMF is called a force because it drives the electrons inside the conductor under the influence of a potential difference. A mechanical force does the same. To any object. It's to drive everything. A mechanical force does the same to any object. अच्छा नाम दिया हुआ इलेक्ट्रोमोटिव फोर्स मैंने कहा नाले फोर्स इलेक्ट्रोमोटिव फोर्स तो यूनिट होंगे न्यूटन नहीं यूनिट्स हैं फोर्स because you go by the definition it is the potential difference between the electrodes of a cell for an open circuit मतलब when we are not drawing the current from the cell it is actually the available energy the energy available to you which you are going to use internal resistance the resistance offered by the electrolyte of the cell the resistance offered by the electrolyte of the cell the resistance offered by the electrolyte of the cell. When a current passes through the external circuit, it also has to pass through the cell. अब देखो ठीक है लिखने नहीं पड़ती है मैं बता सकता है The charge carriers inside the conductor are free electrons but inside the electrolyte are ions. So it is basically when the ions have to move through the dense electrolyte, it's an aqueous solution of either dilute sulfuric acid or a paste of ammonium chloride in a dry cell. So the ions have to move through that. Thus, when the ions have to move through the dense electrolyte, there will be some resistance that is to be offered. So the resistance, obviously, it will only come into play when a current is passing through. Otherwise, the resistance is there. एक वायर का भी रेजिस्टेंस तो होता ही है. एक टेबल पे वायर पड़ी है, उसका रेजिस्टेंस तो है, but it will come into play when a current is passed through. Similarly, about internal resistance. Actually, you think that you have to overcome only the external resistance. That is why you apply a cell. You just know about the collisions of the electrons amongst themselves and with the atoms and ions of the material. But he says that the current has to pass through the cell also, and the total energy that is there with you, the EMF, is to be used not only to send a current through the load resistor, उसको load बोल देते हैं, but also through the cell. The total energy required, the total energy with you is fixed. That energy will be used to overcome the external resistance as well as the internal resistance. The internal resistance छोटा आ होता है, directly proportional to the distance between the electrodes. Obviously, जितना ज़्यादा होगा, inversely proportional to the area of the electrode. There should be no confusion. जिना resistance वाला area पूरा ही लिखला है, A ना लेना, because उथे A is the area of cross section, whereas over here it is the surface area. लिखो surface area. And it is inversely proportional to the absolute temperature. वहाँ पे the resistance was directly proportional to the absolute temperature. इसको भी A क्यों? If the temperature is low, the movement of ions will be less. कार दी बैटरी जिहड़ी है ਆਪਾਂ ਨੂੰ विंटर च तंग करती है, समर में नहीं, because उसका internal resistance बहुत बढ़ जाता है as the temperature is very low. The ions are heavy. जितना उदी temperature ज़्यादा होएगा, उन्हें उनकी kinetic energy ज़्यादा होएगी, and they will be able to reach their electrodes at the same time. Actually, in a cell na, you have one electrode at a positive potential, one at a negative potential, and a steady state is required when one is at a positive. But the moment you begin to use it, because you apply the positive end to one end and the negative to the other, the moment the current begins in the conductor, the motion of ions inside also begins simultaneously, and that is the internal resistance. Okay, ji? Potential difference. The difference of potential between the electrodes of a cell when we are drawing a current from the cell. पहले क्या लैंग्वेज थी बेटे? पहले क्या लिखा था? For an open circuit, पहले यही लिख लो. The difference of potential between the electrodes of a cell for a closed circuit. Symmetry रखते हैं ना? The difference of potential, या ठीक है कोई बात नहीं. The difference of potential between the electrodes of a cell, I'm trying to maintain symmetry ना. The difference of potential between the electrodes of a cell for a closed circuit. That is, when we are drawing a current from the cell. That is, when we are drawing a current from the cell. थोड़ा हो करो जिसे इलेक्ट्रोमोटिव फोर्स लेके आया उन्हों E पालो ब्रैकेट इंटरनल रेजिस्टेंस R पालो पोटेंशियल डिफरेंस V पालो. So once again please, electromotive force, it is the potential difference between the electrodes of the cell for an open circuit. And the meaning when we are and potential difference is अगर देखो आप सिर्फ पोटेंशियल डिफरेंस वर्ड यूज करिए तो वहां तो चल जाता है, जहां कितना फनी लगेगा. पोटेंशियल डिफरेंस क्या होता है जी? पोटेंशियल डिफरेंस इज द पोटेंशियल डिफरेंस बिटवीन द इलेक्ट्रोड्स ऑफ अ सेल फॉर अ क्लोज्ड सर्किट. दैट इज व्हाई आई ट्राइड टू, बट इफ यू राइट इट इज स्टिल ओके, इट इज स्टिल ओके. ठीक है, द डिफरेंस ऑफ पोटेंशियल बिटवीन द इलेक्ट्रोड्स ऑफ अ सेल फॉर अ क्लोज्ड सर्किट, दैट इज ध्यान से सुनना. जो हमने सेल लगाना है वो जो एक्सटर्नल नेटवर्क का रेजिस्टेंस है उसी के क्रॉस लगाना. इट मींस I into total resistance of the network R, that is V is IR. It means that it is the same. It is the same. देखो अब मेरे को एक सेल इधर EMF है E, it could be 5 volts. This is the key. यहाँ तो सुनना बात, there will be a confusion. This could be a single resistor or a network of resistors. If I connect an ideal voltmeter here, voltmeter is actually a device which will read the potential difference between the 2 points it has been connected. It is connected between these 2 points. This point is at the same positive potential as the cell, and this point is the same as the negative potential of. And at this time we are not drawing the current from the cell. ठीक है? For key के open, voltmeter, ideal voltmeter, ideal voltmeter reads take as well as there is no current in the circuit. This E is the potential का difference between the electrodes of a cell when we are not drawing the current. ठीक. For key के closed, a current I. Yeah, let me draw another picture. जिन 2 पॉइंट्स के बीच आपने पोटेंशियल डिफरेंस निकालना है, उन्हीं 2 पॉइंट्स के बीच एक वोल्टमीटर बनाना. The voltmeter reading is actually the potential difference between these 2 points. But when I am drawing a current through the cell, this point is also the same as this point, and this point is also the same as this point. And if there is a current I in the circuit, what is the potential difference between these 2 points? It means at this time the reading is also IR. the potential difference across the cell now is the same as I into this voltmeter will now read I into R. Whether you connect this voltmeter here or you connect it here. What I'm trying to tell you is that the potential difference across the load resistor. Load resistor is the R is the total resistance of the network into the current. That is actually the potential difference across the electrodes of the cell now. For key K close, a current I passes. इसका इंटरनल रेजिस्टेंस R इसका यहाँ भी है पर वो रोल नहीं प्ले करता।
अगर इंटरनल रेजिस्टेंस है तो उससे कम नहीं होगा वहाँ पे, तो ये बात कैसे हो सकती है?
यही तो गल है। इसका इंटरनल यार रेजिस्टेंस तो उसका भी है।
इंटरनल रेजिस्टेंस अगर हो तो वहाँ पे
वो जनाब इंटरनल रेजिस्टेंस है तो है ना, रोल नहीं प्ले कर रही। Internal, exactly. It will, the resistance will play a role only when a current is passed through it. ठीक है ना?
सेकंड केस में रहेगी।
Second case में the EMF is E. When I say EMF, it means the potential का difference when I am not drawing a current from the cell. EMF is E. At this time, this is reading the product of I into R, which I call V. The potential difference across the terminals of the cell now is actually V. और उसका EMF तो कुछ होगा ही ना. When I say EMF, you raised a beautiful point. When I say EMF, the cell has a certain EMF. This does not mean that this is the potential difference across the terminals now. The potential difference across the terminals now is called potential difference, which is also equal to I into R. I think you've saved me from a lot of effort. ठीक है ना कि E पर उसका EMF तो कुछ होगा ना. A current I passes through the load as well as through the cell. As well as through the cell. The potential difference across the cell is now V equal to I into R. यार वही पॉइंट है. At this time, the potential difference across the cell is the same as the potential difference across these 2 points. I into R.
इंटरनल रेजिस्टेंस का उतना रोल नहीं करेगा।
रोल प्ले कर तो रही है।
V इक्वल्स I R प्लस स्मॉल r होना चाहिए।
V एक मिनट. E is I into R plus R. Potential difference between these 2 points and these 2 points is the same, which we have already defined as I into R. अभी आते हैं उसके बाद. We have up to now separately studied EMF and separately studied potential difference. You can improve it. Terminal potential difference. Reason कर सकते. Terminal potential difference. So EMF हो गया, internal resistance हो गया, terminal potential difference हो गया. This is diagram 1, this is diagram 2. From figure 2, using Ohm's law, ये करना पड़ेगा बेटे मेरे साथ. I can wait. You're still drawing your diagrams, I believe. I can wait. hope you have completed this. Okay? You have to be with me. You have to be with me. नहीं तो समझ में नहीं आएगा. सिर्फ कॉपी करके चले जाओगे. वो किताब में भी लिखा हुआ है. अभी है. चलो कल ही करा बढ़िया. लिख लो. बना दे लो. ना पढ़ो. लिखी जाती है नहीं. Is everybody okay?
Yes, sir.
We had a resistor R through which we have to pass a current. It would glow, or it could be a fan, it could be a tube light, it could be a television, it could be anything. We will pass a current through it. This is what we do when we attach a plug and key open. We take a cell and this is the switch. There is no voltmeter. The voltmeter has been simply connected to measure it. Even if I do not apply this, there would be still be a potential difference across the terminals of a cell. I have simply applied it so that I can measure it. Suppose I have to find the potential difference across this tube. I will take an AC voltmeter and attach it across its ends and say, okay, the potential difference across this is so much. Even if I do not attach it, still there is a potential difference across it there. The voltmeter has no role to play here. Absolutely no role to play. It is simply to measure the potential difference. You could be asked a question. You could be given values and asked, what is the reading of the ideal voltmeter? It means you should take the voltmeter away out of the circuit and find the potential difference between the 2 points. It's connected. The voltmeter has no role to play in the circuit up to now. It's an ideal voltmeter. An ideal voltmeter will have an infinite resistance. It will not draw any current. This story will be there in the chapter of magnetic elements. Actually, a voltmeter has a certain resistance. An ideal voltmeter will have an infinite resistance. Anything you have to attend. बिल्कुल समझ में नहीं आएगा. बिल्कुल का मतलब बिल्कुल समझ में नहीं आएगा. We have a cell. A cell is a device which is to maintain the potential difference across the ends of a conductor, because the moment you have A at a positive potential like here and B at a negative potential, the electrons will begin to move through it and will try to balance the potential. A chemical reaction will start inside the cells simultaneously to maintain this potential difference, and even the electrons moving from B to A will never be able to balance the potential, and that will establish a current in the circuit unless this energy vanishes. हो जाता है आपका सेल खत्म हो जाता है, मरना रिमोट ही नहीं चलता. ठीक है ना? So you have some energy ready. The moment you want a current through the resistor, switch on. Switch on. Okay? अब this is share. चलो इसको हटा उसको मत हटा शायद कोई बिगड़ रहा. So if we have a switch on, we begin to draw a current from the cell. We had applied this cell. It is simply energy per unit charge to send the charge through the resistor. But the same energy will have to be used to pass a current through the cell also. So from figure 2 using Ohm's law, total Ohm's law कहता है total energy per unit charge available equal to total current into total resistance. ये पूरे order लग रहा है कुछ भी नहीं है इसमें. So using Ohm's law, E is equal to I into R plus R. Nobody writes anything. Nobody writes anything. E is equal to I into R plus I into R. Now this is called the terminal potential difference. जो voltmeter, the potential difference across the load, which is the same as the potential difference across the cell now. At this instant, in figure 1, the potential difference between these 2 points is E. At this instant, the potential difference is not E. E is simply mentioned there that it is the EMF. It is the potential difference when we are not drawing. The potential difference between the terminals now is the same as across this, which we know. Because we cannot, the reading over here will suddenly reduce. The reading over here will suddenly reduce. EIR plus IR. E is equal to V plus IR. Where V is equal to E minus IR is the terminal potential difference across the cell. It means terminal potential difference across the cell E minus IR or the potential difference across the load I into R is the same thing. Actually, you will become so mechanical with V is equal to E minus IR that it will be completely out of your mind that it is also is equal to I into bada R. Actually, substituting work here. Clearly, terminal potential difference is less than the EMF of the cell. यहाँ तक कॉपी करो, आगे लेकर आओ। अब पूरी हो गई तेरी बात, कासो? Clearly, V is less than E. बहुत इंपॉर्टेंट लाइन लिखी है, पहले सुन लो एक। This is because a part of the cell's energy is used to send a current through the cell also. This is the energy which is used to send a current through the load resistor, which is terminal potential difference. Once again, the potential difference across the cell and the load resistor, when we are drawing a current through the cell, is the same. You can either calculate it by I into bada R or calculate it by E minus. V is less than E. This is because 100% question है school exam में. Define EMF and terminal potential difference. Show that the terminal potential difference is less than the EMF. दोनों. समझ लो, मैंने निकल करके आएगा जब एक्चुअली आएगा आपके पास. This is because a part of the cell's energy is used is used to send a current through the cell itself. To send a current through the cell itself. ठीक है? The product I into R is called lost volts. वो नजर नहीं आता ना? The potential difference across the cell is not I into R. The potential difference across the electrolyte of the cell is I into R. But across the cell is I into bada R. I into R is lost. वो नजर नहीं आता. Measure नहीं होता. Measure indirectly हो सकता है. इसका अलग डिफरेंस हो जाएगा. The product I into R is called lost volts. Let's do a question, a simple question which will make a concept about terminal potential difference and EMF very clear. बहुत आसान सा क्वेश्चन डालते हैं. This is a cell whose EMF is 20 volts and internal resistance is a 2 volts. ठीक है? What is the current through the cell? The current through the circuit is measured by an ammeter. An ammeter will always measure that current which passes through a term. Okay? Because there could be so many branches in the circuit, and the ammeter will always measure the current passing through its own side. So at this time, the current I in the circuit is how much? It is exactly. You will include the total EMF over total resistance. The 20 by 2 is equal to, sorry, 20 by 10 equal to. अच्छा. अब देखना. What is the potential difference across this? How much?
16.
अब वो कहाँ गया? अब वो कहाँ गया? Actually 8 to the 16 plus 2 to the 4. Total the 20 हो गया. Sometimes this is also represented as a, ऐसे बना देते हैं इसको, फिर ऐसे कर देते हैं. ठीक है ना? बच्चों वाली बात है. ठीक है ना? So actually ये चीज है, ये चीज है. तो अब फैसला पूरा हो गया कि भी जो 20 वोल्ट था 16 वोल्ट उसके क्रॉस ड्रॉप हो गया और 4 वोल्ट उसके क्रॉस ड्रॉप हो गया. वो लॉस्ट वोल्ट. It means if I connect, एक मिनट, if I connect a voltmeter here, when the key is open, it will read 20 volts, and now it will read
16 volts.
फिर यहाँ मत देखो, फिर यहाँ देखो. यहाँ तो voltmeter will read 20 volts. ऐसे करते हैं, ऐसे बनाते हैं क्वेश्चन. On similar lines, ना? On similar lines. Reading of voltmeter. K open. कितना? 20 volt. This is the EMF. This is the EMF. Reading of voltmeter K closed. There are two ways now. Two ways. One. पहले I निकाल लो. I कितना? 20 by equal to 2 amperes, and B is equal to 2 into 8 is equal to 16 volts. दूसरा तरीका, V is E minus I into R. E कितना है? 20. I कितना है?
4.
I is 2. R is 2. 20 minus 4 equal to. अब समझ आई बात? हमें कब बोलिए ना? It means 4 वोल्ट ड्रॉप हो गया सेल के क्रॉस. Rahul, I into R is not the potential difference across the cell. That is I into बड़ा R. I into छोटा R is our lost volts. That is the energy that has to be consumed to pass a current through the cell. So चाहे आप I into बड़ा R कर लो, चाहे आप E minus I R कर लो, बात तो वही है. टोटल तो उतना ही होना चाहिए ना, 16 वोल्ट उसके क्रॉस ड्रॉप हो गया, 4 वोल्ट उसके क्रॉस हो गया. If the internal resistance is 0, then EMF is equal to terminal potential. ठीक है, नोट पार. If small r is 0, तो V is equal to E minus IR. तो V is equal to. सवाल आज that can the terminal potential difference be equal to the EMF? Yes. If the internal resistance is 0. हो नहीं सकता. It's an ideal situation. ठीक है? It's an ideal situation. It's an ideal case. बता दो. बात आसान है, ऐसी कोई बात है नहीं. Especially after this discussion. So we repeat our initial definitions. That EMF क्या है जी? It is the potential difference across the electrodes of a cell for a and terminal potential difference is the potential difference across the electrodes of a cell for a closed. That is when we are drawing a current in the cell. And terminal potential difference will always be less than the EMF because a part of the cell's energy used to be वो I to छोटा आ रहा है, lost words है. ठीक है, अब जितने सवाल कर लोगे उतना बात ज़्यादा अच्छी होगी. Ignore God. How is the terminal potential difference affected? How is the terminal potential difference affected? If the load resistor increases, if the load resistance increases, and it remains the same, increases, K decreases. K will depend upon the value of the load resistance. How is the terminal potential difference affected if the load resistance increases? And Srishti believes it's the same. Same answer or it will be the same? तो छोटा r तो नहीं, उसको तो नहीं कोई बदल सकता. तो फिर ना ही कोई E को बदल सका. I आप मानते हो कम हो जाएगा. It will increase. It will increase. From V is equal to E minus IR. ठीक है? As R increases, I decreases. Therefore, V increases. Simple. And if we plot a graph between terminal potential difference and load resistance, वो ऐसा बहुत इंपॉर्टेंट सवाल है. कमाल. An increase in the load resistance will decrease the current. निकाल के देख लेते हैं. निकाल तो बड़ा क्लियर है वैसे, ऐसी कोई बात है नहीं. दोनों फ्रैक्शन वैल्यू आनी है. 10 volt 2 ohm. Okay, this is 8 ohms. कितना terminal potential difference? What is the terminal potential difference? 8 volts. Current I is 10 by 10 equal to 1 and V is E minus IR. You can say I into बड़ा R also. Actually मैं हमेशा I into बड़े R से कर देता हूँ. पर इसको मानते हैं. This is 10 minus 1 into 2. कितना आया? डबल कर देते हैं लोड रेजिस्टर. 18 कर दूं? आसान हो जाएगा. दूसरी बारी ये 18 ओम कर दिया. ये 10 वोल्ट ही है, ये 2 ओम है. कितना आया आई डैश बोल दे. 10 by 20. Double potential difference now. कितना आया? तो वो ऐसा ऐसा बढ़ता है और तभी वो ऐसे है. Because you know the shape of the graph is according to this. This is I. This is I. आपको तो increase decrease तो कर देते हैं ना. So it is one of the examiner's favorite question. ठीक है. Okay. Numerical solving से पहले how much time did you do?
5 minutes.
Just 5 minutes. Okay. We can do cells in series in parallel tomorrow and circuit solve करके छोटा है मेरे. ठीक है. आज बहुत काम है आपके पास. ठीक है. संडे को आई थिंक आज वेडनेसडे तो हो ही गया. You can come and take a test on Saturday morning, let's say. Saturday morning 8 o'clock, electrostatics. Come and give me a test. Saturday क्लास है, उसके बाद आ जाना. आर्टिफिशियल की क्लास के बाद आ जाना मेरे पास 8 बजे. हैं? चले जाना 9 बजे. 8:45 आ जाना. आप किसी और टाइम के पास आ सकते हो. ठीक है. You come at on Sunday या घर लेके जा सकते हो. But mainly we have a test on Saturday 7:30 after our sister's class. Okay. Look, let's start with the same kind of after our sister's class. चाहे 7:35 हो. मैं सोचता हूँ वही बातें हैं. ठीक है. नहीं यार. कितना हो गया? 4 हो गया. 4 and 3, 7 and 3, 10. Okay. 20 volts. Find the potential difference across this. Across, okay. A, B, C, D, F. Find the equivalent resistance. अच्छा एक और पंगा करते हैं. रुको. ऐसे होगा. ये बैटरी है. ठीक है. ये 1 ओम है. ओके ये 2 ओम है. और ये दिस इज 10 volts and 1 ohm. तो इक्विवेलेंट रेजिस्टेंस निकालो, फिर टर्मिनल पोटेंशियल डिफरेंस अक्रॉस द सेल। अब देखो ना, E minus IR seems easy now instead of I into बड़ा। क्यों सुप्रीति? मैं कहता हूँ ना, क्योंकि आप इक्विवेलेंट तो निकाल लोगे तो E minus IR will seem easy, you can adopt any। टर्मिनल पोटेंशियल डिफरेंस कितना हुआ जी? R कितना आया? नहीं R होता है लोड रेजिस्टेंस। लोड रेजिस्टेंस 9 ohms। अब कोई ये ना मेरे को कहे कैसे आया, मर जाऊंगा मैं। ठीक है ना? सो 9 ohms। करंट कितना आया? 10 by 9 plus 1 equal to 1 ampere। टर्मिनल पोटेंशियल डिफरेंस E minus IR। E is how much? 10 minus 1 into 1 equal to 9 volts। Everything as now। ठीक है? And potential difference across CD। अच्छा एक और करते हैं, देखिए कनेक्टेड एमीटर है, find the reading of the ammeter and potential difference across C and D। यहां करंट कितना आया? 1 एम्पियर। ये डिवाइड हुआ, इट विल डिवाइड, मेरी बात सुनो ध्यान से, नहीं सुनोगे भाई। 8 ओम से 4 ओम का कोई फर्क नहीं है, चाहे यहां लगाओ चाहे यहां लगाओ। दिस 1 एम्पियर विल डिवाइड अमॉन्ग 6 and 12 in inverse ratio। So this is I1 and this is I2। This is I2। What is I2? It will divide in inverse ratio। It will be 1 into 6 upon 80। This is 1 by 3 amperes, which is the reading of ammeter reading। And the potential difference across C and D। If you would be thinking कि हम सर इसके क्रॉस निकाल लेंगे और उसको फिर डिवाइड कर देंगे, पर जैसे मर्जी कर सकते हो। I think doing I into R is much easy। So this is I2 into resistance of the arm CD। I2 is how much? 1 by 3 and RCD is 4। The answer is 4 by 3 volts। आप कैसे कर रहे हो जितेंद्र? अगर वैसे करना मैं कर देता हूं। 8 से 4 12 और 6 पैरेलल गिव यू, दिस इज अ 4 ओम हियर। 4 ओम में से कितना करंट जा रहा है? 1 एम्पियर का। तो इसके क्रॉस तो 4 वोल्ट है, इसके क्रॉस 4 वोल्ट है, मतलब इन दोनों के क्रॉस सम 4 वोल्ट है। डायरेक्ट रेशियो में डिवाइड करोगे तो 4 into 4, the 4 volt has to be divided। इसके क्रॉस पूछा है 4 upon, यार वही तो किया है 4 over 12 into 4, वही तो किया है 1 by 3 into 4, वही तो किया है। समझ आई बात? So it is the same thing whether you divide the potential or divide to the more you practice the more we learn। ये समझ आई बात? अगर आपने डिवाइड करना था, you will have to first find the potential difference across this point। Across this point you have a resistance of 4 ohms। 4 ohms into 1 is 4 volt। 4 volt is the sum of the drops across this। इसके क्रॉस निकालना है 4 into 4 upon 4 plus 8 12। हाँ ठीक है, और इसके क्रॉस निकालना है 4 into 8 upon 12। मैंने क्या किया? करंट को डिवाइड कर दिया। करंट इज डिवाइडेड इन इनवर्स रेशियो। इनवर्स रेशियो मींस टोटल करंट आई है, I2 निकालना है, I into this over the sum। It would go like this, you know। Directly if you have to divide the current, दो के लिए ही है। I, this is I1, this is I2, this is R1, this is R2। ठीक है? I is I1 plus I2 and I1 R1 is equal to I2 R2, and I1 R1 is I2 is I minus I1. This will give you I1 to be I into R2 over similarly I2 is I into ये मैंने प्रूव कर दिया, वैसे कोई जरूरत नहीं है, इनवर्स रेशियो में डिवाइड हो जाता है। Have there been 3 resistors here? तो आपको करंट ही निकालना पड़ता है। ठीक है जी? You can do as many questions as you can. Opt for the series parallel combination first, and because the questions on temperature coefficient of resistances are very boring and sickening. ठीक है? You please opt for the resistance in series parallel combination so that you get used to it. ठीक है? Okay.